Okay, number 66, a high diver. We have the mass of the high diver, 70 kilograms. Jumps off a board that's 10 meters high, so we'll put that on here. And so the diver goes like this. So starting from rest, the diver goes down like this towards the water. Now let's say she does what you're never supposed to do, which is dive in head first. You guys know that, right? Don't dive in head first, because what if it's only like that deep, right? Then you're in trouble. Okay, so anyway, but she's going to be fine because the water is very, very deep. She's an experienced cliff diver. Okay, this problem. Okay, if you had difficulty with this problem, it's a sign convention problem. Like, you got to pay attention to your sign conventions. So should we say the typical sign convention is we say that up is plus and down is minus? Should we go with that? So her velocity when she hits the water is going to be negative, right? It's going to be negative because she's traveling downward. Now, here's the big picture for the problem. So she hits the water, and then the water is going to bring her to rest. So here she is down here under the water like this. Velocity is going to be 0 after the water brings her to rest like that. But then the question is, what average upward force did the water exert on her? So we're going to do a free body diagram. As she's brought to rest, we're going to do a free body diagram on her, like right about here, like right as the water's acting on her. So let's do that. Let's do the free body diagram. Here she is. I'm just going to kind of focus in on this area right here. So let's do a free body diagram for her as she's being brought to rest. So here she is. The water's acting upward. So what are the forces on this diver? We have gravity down, right? mg is still acting even though she's underwater. Gravity still acts underwater. And then what's the upward force? Let's just call this the force of the water. Now, which of these two forces has to be bigger? Is the force of the water bigger, or is the force of gravity bigger? The force of the water is bigger, because think about it. If the force of gravity was bigger, what would be happening to her under the water? She'd be accelerating. Wouldn't that be scary? If you start accelerating deeper and deeper and deeper and deeper, right? So, water is your friend and slows you down, so that way you have a chance to come back to the surface and get some more air. Okay, so the net force, so back to what I was saying, the force of the water is going to be larger than the force of gravity, so therefore we can say the net force is up, right? So therefore, which way is the acceleration going to be? Up. So our acceleration should be positive, right? While she's in the water. The acceleration should be pointing up, which is positive, back to our sign convention. So how do we figure out the force of the water? Well, what comes after the free body diagram? After a free body diagram, what do? Sum the forces. Okay, so we're going to sum the forces. So force of water is positive, up is positive, minus mg down, right? So this is the sum of the forces, and what is the sum of the forces always equal to? ma. So therefore, the force of the water, I'm running out of room, let's go over here a little more. Therefore, the force of the water should be equal to ma plus mg. You can factor out the m, a plus g. The only thing we have to find now, in order to find the force of the water, the only thing we got to get is what? Her acceleration while in the water. So what's her acceleration while she's in the water, right? We know that it takes 2 seconds to bring her to rest, so t equals 2 seconds. They gave that to us right here. 2 seconds, and we're looking for a. So now we got to do some what? Kinematics. We got to do some kinematics. Let me make some room up here. We'll get rid of this. Okay, so it's actually 2 kinematics. So we got to do 2 kinematics. The first thing we need to calculate, she jumps off the cliff or the diving board. What do we first need to find? Her velocity right when she hits the water. What's her velocity when she hits the water? So we're going to go like this. We'll go V final squared equals V initial squared plus 2AX. V initial at the top was 0. So V final is going to be square root 2AX. And remember, square roots are always plus or minus. They're always plus or minus. You got to pick which one. So this is going to be, which one? Is it plus or minus? Minus, because she's going which way? Down. So it's going to be minus square root 2 times, what's her acceleration as she falls? Negative 9.8. Negative 9.8 meter per second squared. And then what's her displacement? 10 meters. But that's actually negative 10 because she went down 10, right? So this works out to be 14 meter per second. So she hits the water going 14 meter per second downward. Okay, now we go to the next part of the problem, which is her in the water. So can we find her acceleration? Now V initial is 14, V final is 0, and the time is 2. So is that enough information to find the acceleration? Yes. So we're going to use a kinematic. We'll go V final equals V initial plus AT. That's a good one. So what's her V final? 0. She stops, so V final is 0. So solve this for A now. A is going to be negative V initial over T. So hold on, you got to pay it. This is sign conventions, right? Watch. Negative. Now her V initial was what? Negative. So what's going to happen to those negatives? They're going to cancel. Time is 2 seconds. So this gives an acceleration of positive 7. And does it make sense that her acceleration's positive? Because when she's in the water, is she accelerating upward or is she accelerating downward deeper and deeper and deeper? She's accelerating upward, right? She's slowing down, so her acceleration's up. So this acceleration comes out as positive 7. Positive 7. And then we can plug that in over here. The force of the water, so we take her mass, which is 70 kilograms, and then we go acceleration, which is 7, plus, now do we make gravity negative right there? Is gravity going to be negative 9.8? Nope, because look right here. We already called gravity negative, didn't we? We already called it negative, so don't call it negative again. So it's going to be plus 9.8. And then this gives the answer. Force of the water is going to be 1,176 newtons.